Hi everyone, today's lesson from Unit 1.2 is about a specific type of transformation called a reflection. In a reflection, reflected images are the mirror images of the pre-image. Images of reflections are isometries. In other words, the pre-image and the image are congruent. So if you're working with a triangle, the original picture, called the pre-image, and the new picture, called the image, will be a pair of congruent triangles. And remember that an isometry is a transformation that creates a congruent figure. In other words, they're the same size and shape. And this means that angle measure is preserved and distance is preserved. For our reflections, we're going to be doing what are called line reflections. The mirror line is called the line of reflection. The image is a flip of the pre-image. Reflections may occur in any line of reflection, but we will concentrate on reflections across these lines of reflection. The first type of line of reflection that we'll work with is just the x-axis. I'm going to highlight the x-axis in red in this first graph. And the equation of the x-axis is y equals 0. So I could either ask you to reflect an image in the x-axis, or I could tell you to use the line y equals 0. And notice that when you perform the reflection, you want to go the same distance away from the line of reflection, but in the opposite direction. So we are going to learn some rules for reflections, but you can also do this by counting. In other words, if I take a look at the point C in my first triangle, and I notice that it is 2 units away from my line of reflection going up, to find its mirror image point, I'd go that 2 units to the line of reflection and go 2 units in the opposite direction to find C prime. And you can continue that with the other 2 remaining points. Like point A is 1 unit above, so I know I want to go 1 unit below. Point B is 4 units above, so come down to the line of reflection, count 4 units, and then go 4 units below. In the next line of reflection, we have the y-axis. This time I'm going to highlight the y-axis in blue. So if this is my line of reflection, it has an equation of x equals 0 because every point on that line has an x value of 0. And we can reflect the triangle ABC in the y-axis, and we get triangle A prime, B prime, C prime. Again, we will learn a rule for doing this reflection, but we can also use counting. So take a look at point C, and I notice that it's 2 units to the left of my line of reflection, so C prime is going to be 2 units to the right, but go along the same horizontal line there. Point B is 4 units to the left, so B prime will be 4 units to the right. Again, we're looking for the mirror image point. For our next line of reflection, we have the equation y equals x. Now that line has a slope of 1 and it has a y-intercept of 0. So if you remember from Algebra 1, when you graph that line, we start at the origin. We want to go up 1 to the right 1, up 1 to the right 1. So all of these points that I'm drawing represent the line y equals x. Now usually when I draw the line of reflection, I draw it as a dotted line. Okay. So again, we will learn a rule for getting the coordinates of the new points, but you can also apply the counting method for this one, except in this case we have to go along the diagonal. For instance, I'll do this in red. This point C is at negative 2, 2, and we want to find its mirror image in that line of reflection. So we have to go along the diagonal here. So I went across 2 squares along the diagonal right here to get to the line of reflection, and I want to repeat that pattern on the opposite side. Okay. So point C should be at 2, negative 2, so it should be down just slightly. Okay. All right, we can do that with point A and with point B as well. Okay, our next line of reflection is the line y equals negative x. Now this line has a slope of negative 1. Still has a y-intercept of 0, so it's going to go through the origin, but this time we'll go up 1 and to the left 1, up 1, left 1. And so this dotted line would represent the line y equals negative x. Okay, again, in a few minutes we will talk about a rule for figuring out the new coordinates, but you can also do this by counting. For instance, I see this point right here, which should be labeled with A, is one diagonal of one square away from the line of reflection. So if I go one diagonal of one square away on the opposite side, that would give me A prime. Okay. For point B, it's a little tricky. You come down 1, 2, 3 diagonals and a half. Okay. And then we want to go in the opposite direction, so there's half, and then 1, 2, 3 diagonals, there's B prime. But you should also notice a pattern between point B at 2, 5, and the new coordinate for B prime, which is at negative 5, negative 2. And this is helping us to come up with our rule. If you notice that if this is x and this is y, our rule would be to say we want to switch the x and the y and change their sign. So it would be negative y, negative x. Okay, with any vertical line, in this case the line is at x equals negative 2, there's the equation. A vertical line always has the equation x equals a number because every point on that line has an x value of negative 2. Now these are so much easier to count than in y equals x and y equals negative x. So if I check out point A to the left at negative 5, 4, I notice if I count 1, 2, 3 squares to get to my line of reflection, then I know I want to go 3 squares in the opposite direction. So A prime would have to be at positive 1, positive 4. Do the same thing with points B and C. B is 2 to the left, so come to the line of reflection, go 2 to the right, there's B prime. C is 4 to the left, 1, 2, 3, 4, and then go 4 to the right, 1, 2, 3, 4. Okay, so for a vertical line, its equation is always x equals a number, right? And we can use counting to graph the image. Okay, for a horizontal line, horizontal lines always have the equation y equals a number because you're saying every point on that line has the same y value. You're going up the same number of spaces or down the same number of spaces. So similar to working with vertical lines, we can just use the counting method for figuring out the new points. So point A is 1 unit above my line of reflection, so A prime will be 1 unit below. C is 2 units above, so count till you get to the line and then go 2 units below, and there's C prime. And you can do the same thing with point B as well. Alright, next we'll try some examples. So at the top of the page we have some rules. If you're doing a reflection in the x-axis, every point xy becomes the new point by doing x comma negative y. All you do is change the sign on the y value of your point. If you're doing a reflection in the y-axis, every point xy becomes a new point by changing x to negative x and then keeping y the same. So all you do is change the sign on the x value. If you're doing a reflection in y equals x, every point xy becomes a new point by switching the x and the y, so it becomes y comma x. And for a reflection in y equals negative x, every point xy becomes negative y comma negative x. So you switch the x and the y and you change both of their signs. Okay, for other vertical and horizontal lines, count boxes. Okay, your points need to be the same distance from the line of reflection. That's what this stands for. LOR is line of reflection. Or you can also use a paper folding method that we may demonstrate in class. Okay, in the first example it says the vertices of triangle ABC are point A at 2, 4, B at 6, 3, and C at 3, 2. So take a minute to plot those 3 points on your graph. Okay, when you're doing yours on graph paper, please use a ruler, even use colored pencils to show the difference between each of your figures. Mine are a little messy, but that's because I'm limited to what the stylus can do. Okay, the first thing we're asked to do is graph the reflection of triangle ABC in the x-axis. So what I would do is take my ruler and a colored pencil and mark a dotted line along the x-axis. And this is my line of reflection. Okay. Now I'm going to keep going in red to show my image under this reflection, and I'm just going to use the counting method. So point A, I notice, is 4 units above. If I come up 1, 2, 3, 4, 4 units away from the line of reflection. So I'm going to come back down to my line of reflection and go 1, 2, 3, 4 units below. So A prime has the coordinates 2, negative 4. For C, I notice that it's 2 units above, so come down 2 to the line of reflection, then go 2 units below, and this is where C prime would be. Now, because I'm using dots to show that I'm counting, I'm going to go ahead and connect those 2 points with a line segment so I don't get confused later on. For point B, I see that it's 1, 2, 3 units away from the line of reflection, so we want to go 3 units away in the opposite direction of point B. So come down 1, 2, 3, and put B prime right there. So connect those 3 points, and you now have the mirror image of triangle ABC reflected in the x-axis. But if you look up above, you can look at this for a way to find your points as well. Okay, so if we're reflecting in the x-axis, then I know that A prime would be at 2, negative 4, following this rule. You keep the x the same, and you change the sign on y. B prime would be at 6, negative 3, and check it out, it is at 6, negative 3, and C prime would be at 3, negative 2. So you can plug the points into the rule if you would like to do the reflection that way. Okay, the last part of this question, we're also asked to take triangle ABC and reflect it in the y-axis. So just highlighting the y-axis in blue. And I'm going to stick with the counting method. So point A reflected in the y-axis would be over here. And I'm going to call it A double prime because we already used A prime. So again, counting squares to find that new point. C is right here. It's 3 units away. 1, 2, 3. So we want to go 3 to the left. 1, 2, 3, and put C prime right there. Okay, point B. It's 1, 2, 3, 4, 5, 6 units to the right. Come to your line of reflection and go 1, 2, 3, 4, 5, 6 units to the left. So it would be B double prime, and that should be C double prime. Okay, that's it for number 1. Let's go on to number 2. Okay, so in the second question, I've started by graphing the triangle DEF, whose coordinates for D are 4, negative 2, E is at 7, negative 1, and F is at 7, negative 5. And we want to reflect triangle DEF in the line y equals x, and then in the line y equals negative x. So we're going to start by graphing the line y equals x, and I'm going to do that in red. Y equals x goes through the origin and it has a slope of 1. So if you go up 1 and to the right 1, just think of this as the diagonal line. It cuts the graph in half. If it helps you to see it better, make it a dashed line. Okay. Alright, this one, we can follow the rule. If you take a look up above, the rule for reflecting in the line y equals x is if you take every point x comma y, you're going to switch it just by doing y comma x. So the point 4, negative 2 would become negative 2, positive 4. So this would be D prime. Okay, the point E at 7, negative 1 would become negative 1, positive 7. So there would be E prime. And then the point F is at 7, negative 5. So F prime would be at negative 5, positive 7. Okay, take a second to connect the dots. Okay, for the line y equals negative x, we have a rule for that as well up above. Every point xy becomes a new point by doing negative y, negative x. So for this point D at 4, negative 2, reflected in the line y equals negative x, let's draw that line first. Start at the origin. Has a slope of negative 1, so it's going to look like this. If you want to see it better, make it with a dashed line. Okay, So again, point D is at 4, -2. So if we want to follow that rule, then we'll say D double prime would become 2, because we want to take the opposite of y, comma, -4. Okay, opposite of x right there. So go to +2 and then to -4. And this would be D double prime. For the point E, if we follow that rule, E double prime would then be at 1, comma, -7. So you're switching the x and the y, and you're changing the signs. And then finally for point F, to get F double prime, we want to switch the x and the y, we'll get 5, comma, -7. And there's your triangle. Okay, for our last example, we want to start by graphing the points for triangle WYZ. So W is at -2, 5. Y is at -2, 1. And Z is at the point 1, 1. So plot those points and turn them into a triangle. Okay, the first thing we are asked to do is to reflect this triangle in the line x equals -3. Remember that if it's x equals a number, it's a vertical line. So come over to your graph and draw a vertical line right down there through the point where x equals -3. So the easiest way to do this one is just simply by counting. So start with point W. It's 1 unit to the right of the line of the reflection. So go 1 unit to the left, and that'll be W prime. Okay, for Y prime, again, it's 1 unit to the right, so come back to your line of reflection and go 1 to the left. And for Z, it's 1, 2, 3, 4 units to the right. Come back to your line of reflection and go 1, 2, 3, 4 units to the left. And that will be Z prime. Connect the points, and you have your triangle. Okay, for our last one, our line of reflection is the line y equals -1. That's a horizontal line down here where y is equal to -1. And again, we're going to do this one by counting. So point y, starting with that, is 1, 2 units above the line of reflection. Come to the line of reflection and go 2 units below. 1, 2. So this will be y, we'll say double prime. Now point Z is also 2 units above, so come to straight down to your line of reflection, go 2 units below, and that's Z double prime, and connect those points. Okay. Finally, point W, it is starting at point W, it's 1, 2, 3, 4, 5, 6 units above, so we want to go 6 units below. So 1, 2, 3, 4, 5, 6. And there's W double prime. Connect all 3 of your points, and you see that your triangle is the mirror image of our original triangle, and it's just reflected over the line y equals -1. All right, good luck on your homework.